This is a video on section 1.4 going over the problems, which were in number 4, where I give you some roots and then you have to come up with a quadratic that has those roots. So there are multiple answers, but I just want to make sure there's not a bit of confusion about a few things. So first of all, I say integral coefficients, meaning the quadratic you come up with has to have coefficients that are integers. Okay, so let's look at part A here. So here are the two roots. So here's how you always want to begin. If you're given the two roots, we're talking about we're starting with a quadratic in root form. So f of x equals a. So I want you to put that a. Don't assume the leading coefficient is 1. And then if something's a root, x minus that is a factor. So if 2 plus root 7 is a root, x minus 2 plus root 7 must be a factor. Same with x minus 2 minus root 7. Why is that the case? Well, remember how you get roots. If it's in factored form, if you set each factor equal to 0 and solve, that's how you'd get the roots. And notice here, if I set this equal to 0, I would get the roots 2 plus or minus root 7. Okay, so you can't stop there. Let's FOIL it out here. I'm just going to keep the a out in front for now. And so FOILing this out, I get x squared minus, and I'm going to leave, actually, maybe I'll do a bracket. I'm going to leave the 2 plus root 7 in parentheses right now, just to make sure I don't make a careless error. And then minus 2 minus root 7x. And then plus, we're doing 2 plus root 7 times 2 minus root 7. Okay, so a, and now I've got x squared minus 2x plus root 7x minus 2x. Oh, sorry, it's not plus root 7x. Let me go back there. Hold on. This, I forgot to distribute the negative there. This should. So again, that should have been minus root 7x. I need to distribute the negative. Minus 2x plus root 7x. And then let's FOIL out the constant term. Luckily, it's a difference of squares, so the middle term will cancel. So it's plus 4 minus 7, because root 7 times root 7 is 7. Okay. And so the radicals are canceling, which is great. So it's x squared minus 4x. 4 minus 7 is negative 3. And so now in this case, you really can, a can be anything except 0, because anything I put in for a, as long as I shouldn't say a can be anything, any integer, because we want integer coefficients. So it can be anything but 0. So I'll just say let a equal 1. You can let a equal whatever you want in this case. So my function would be x squared minus 4x minus 3. Okay. Let's do this next one. So again, start the same way. You're going to do x minus the root. So minus this 1 minus I root 5 over 4. And x minus 1 plus I root 5 over 4. All right, now just the messiness of FOILing this out. Still, I'm going to just leave my a in front. I've got a x squared. I like to do this extra step of splitting up, of not doing too much at once, just so I don't make a careless error. And then minus I plus, what am I doing? Minus 1 plus I. 1 plus I root 5 over 4x. And then the constant term is going to be plus 1 minus I root 5 over 4 times 1 plus I root 5 over 4. So just a lot of details to keep track of here. Okay, so I've got x squared, and I'm going to have this, maybe I'll split up this fraction. It's going to be minus 1/4 x plus I root 5 over 4x, then another minus 1/4 x minus I root 5 over 4x, And then here, well, if I multiply, I've got this, the denominator 16, and then the numerator, luckily a difference of squares, so I'm going to get 1 minus 5i squared. I'll deal with that shortly, because remember, I squared is -1, so those i's will actually go away. All right, before I think about a, let's clean a few things up. Luckily, which was the intention here, the i's should go away. And I know I want integer coefficients, so at this point I realize, all right, I gotta get rid of the fractions, so what can I have a, b, so that the fractions go away and I have integer coefficients. So I'm gonna say, let a equal 16. That's the smallest integer it could be for the fractions to go away. So if I do that, and I'm gonna distribute it through, actually, maybe I'll wait one more step before I distribute it through. So I'm just gonna put the 16 outside, and I'll say x squared minus a 4x minus a fourth x is minus a half x. And then I have, well, minus 5i squared is plus 5. So it's going to be plus 6 sixteenths. And in fact, actually, I didn't need to I could have made a smaller. Now that I think about it, let's do that. I mean, you can have a 16, it's fine, because there's multiple answers for that, but I didn't need to have a 16. I actually, now that I see that I can reduce this fraction here, I actually can have a smaller value of a. Let's just keep it at 16, fine. Let's just keep it at 16. Again, there's multiple answers here. Okay, so then distributing the 16, I get 16x squared minus 8x plus 6. So that would be my function with integer coefficients. You could see I could also have divided all of this by 2 and have 8x squared minus 4x plus 3. It all depends on when you choose, at what point you choose to declare what you want a to be. All right, so the last one here, again, multiple ways to think about it. However, I think there's an easier way versus a hard way here. So one thing that sometimes people do is, so I've given you 3 points on the parabola. So some people create a system of using ax squared plus bx plus c and plugging in x and y, because I've given you x and y points, and getting a system of 3 equations and 3 unknowns, which you can totally do. However, I noticed 2 of these points may be helpful to me here because I have 2 x-intercepts. So because of that, I can actually do something else. So let's think about what we can do. If I have the 2 roots, so say I have, and again, multiple ways to think about it. So if I have the 2 roots, often when you have the 2 roots, you think, oh, I have x root form, right? X minus 1, x minus 5. And so in which case my only unknown here is my a value. So, but I do have another point. So let's see if that helps me to find a. The other point I have is 0, 10. So if I plug in 10 for y and 0 for x, let's see if that helps me find a. So I've got -1 times -5. At 5a equals 10. A is 2. Which actually is very helpful. So f of x is going to be 2, x minus 1, x minus 5. Now, remember what the directions say. Put it in standard form. So this isn't a big deal. We're just going to FOIL it out. So x squared minus 6x plus 5, and then multiply it by 2. So 2x squared minus 12x plus 10. So that's probably the easiest way to do it. Another way to do it is you could have... finding the h is the average of the 2 x-intercepts, and then you could use vertex form, but you have 2 unknowns in that case. I think that's what I did in my solutions, but I actually think this is, well, I know this is an easier way to do it. It's just directly work with root form. Okay, so hopefully that was helpful.